Hello, in this video I will be showcasing thermal vision as previously promised. So currently we are in black hot. With the press of a button I can change into any type of thermal vision that I desire. Each headgear has a range that it can see through. For this the range currently set to 0 and 50. But I can set it to -100 to 100 and everything is calculated in Celsius, so it's easier to understand what is happening. As well as I'm going to show a bit of an inspector as well as the thermal shaders that work. So first of all, the grid temperature manager works with tilemap thermal shader primarily, and it changes the entire tilemap grid. Most thermal shaders use mostly globe overrides, so I can change shader set global, for example vector, and change all the materials that use said shader in an instant rather than looking for everything on its own. The way that the tile maps are generated is through a texture, which is then inserted into a material. So this is the debugger. For starters, let's just use the debug texture that I used, and we can just simply click generate texture and the texture will be generated. So this is the texture. Because the range is quite low and the spectrum range is between -100 and 100, it's quite strong. So I'll change the spectrum for the visors to be able to see what's happening more clearly. And to do that, we just click on heat vision, the goggles, and here's the range. So we just change it to -100, 100, and now once we click play, now the vision will be quite different. Because the range is bigger, the spectrum doesn't work as well. So let's just use the debug texture now, and you can see the spectrum quite more clearly for all types of ranges. Of course, goggles won't work with the entirety list. Some may only have 3 different spectrums, some 2, some maybe have custom spectrums specified for this game to find enemies better, and so on and so forth. But that's in the future. Now let's play a bit more. In this example I have changed the debug values quite here. So I said that everything is being debugged both here and here. And now what debug temperature, incremental, and debug temperature ratio means. So debug temperature is an universal range temperature, and it changes the entire location based on that value. So if it's 5, then the temperature increases on the entire sprite to 5 degrees more. The debug temperature incremental works with debug temperature ratio, and it allows for certain parts to get heat up more than other parts. For example, if currently I will set no noise and have 0 debug temperature and generate, you will notice that the walls are quite different than if I set to 1. Because the walls have a different temperature incremental. Thus inside heats up slower than the outside. And for this we just currently set it to random values between 0 and 1. So we get this. Now this pretty much multiplies these values, so we have temperatures between -10 and 20, and also I set my visors to see values between -10 and 50 currently. So this is how it all looks. Now there's a thing called subtiles, and there's thermal map scale. So currently there are 3 subtiles per tile, and if I set this, you will notice that the map gets even more randomized, because each tile has currently set to having 9 subtiles in it. But I can change the value into quite big. For now the game runs in 32x32, so that means that every pixel is a random value. The game actually does not diminish efficiency on CPU end, because it's using a texture and the texture just stays the same. But if I wanted to update this, it would be way more costly, especially if I wanted to create temperatures that could move around, which I plan to do so that's not possible. Probably I'm going to use 3 subtiles, 2 subtiles, or even 1 subtile instead. But for now I plan on doing 3 subtiles and optimizing towards that. Now the way thermal is actually drawn, the idea is that camera's culling mask ignores every object that contains heat layer. And when I click on thermal, it just sets that you don't ignore heat layer, you ignore other layers instead. And that's how I see thermal and don't see thermal, as it's just simple culling mask changes. That's all there is to it. As for how I change, as I mentioned, everything is global. And now I'm just going to show you the shaders themselves. First I'll just show the shader graph for sprites, as it's pretty much the simplest. I'm using only one texture to create the effect, and each values does different things. You could technically work with only one, but I wanted to make it better. So the red simply defines the basic color range. So it defines what places are hot, what places are cold. But for development, let's say one to create a very cold object, so -10 to 60, while another wants to create a hot object, so the range is completely different. Thus, we remap this to the material spectrum range. For example, this texture was developed using the range of 10 and 50. And this is important to know what temperature this object works with. Now we have the temperature in this. Down below we have a ratio calculator. So the green and blue defines ratio 0 and ratio 1, and GB ratio is current ratio between them. So one could be, for example, flashlight while it's not active, thus the flashlight gets colder, thus less heat. Or the flashlight is active and it gets hotter as long as the further you're using. Or maybe a gun before firing and after firing, and wanting to actually simulate the barrel moving and getting hotter as the bullet flies. So this is possible thanks to using GNB and the ratio, as I can mix the colors between them. As well as this is how the walls work, as I'm using one to pretty much heat up the walls, while the other can be used to heat up everything. Default C and currency is just used to make life easier to develop, as default C is the temperature that is the default. So for this instance I was using tried using human temperatures within that range, so it's 36.6, but the human temperature can get colder or hotter depending the atmosphere, or for example if the object is on fire. Thus the current Celsius helps me with that, as if I made the temperatures within the range and 36 and I set the current temperature to 36, it would get hotter even than normal. Thus this pretty much default temperature negates the current temperature a bit and sets it as the default temperature to start calculations from. And once that's done, it just simply adds to it. Then we work with goggle range, which simply defines the range that the goggles work on, and we use that to the thermal spectrum shader subgraph. By the way, both thermal spectrum, thermal temperature and ratio calculator are subgraphs. The ratio calculator and thermal temperature is quite easy. Even thermal spectrum is quite easy, as pretty much this is only an UV mask, and this thing is the important factor. And this is just spectrums, and they are pixel 1 pixel height and 128 pixels wide, showing the entire spectrum of said goggle range. And this goes to the UVs, and the output is between 0 and 1, and it defines the X coordinate of the UV to pick the color from, and it goes to the base color, while this just goes to alpha. Thermal shader is a bit more difficult, as it has a global range for it. This is essentially a test texture, so that I would be able to see how everything works. For now, let's just delete UVs for easier seeing how everything moves easier. So this is the final thing that you can see using this texture. The red is quite different, as it goes from here to here. Well, technically from here to here, and you can see that this place is affected more than this place, because this has more temperature to begin with. And as for this, the red, actually there's a lot more, so I'll just delete all of it to be able to see it. So the temperatures of red, green and blue for world texture works quite differently, quite a lot. The red is default temperature. This just increases and decreases the color globally. This pretty much increases the color via ratio, so you can see that because the ratio is here, some places get hotter more than the others, while this just increases it overall. And max temperature is the temperature that is set that this can get. So this goes in 0 to 1, and this simply multiplies those values and then adds it, goes to remap, does the goggle range the same as thermal shader, and then does the same thing within the thermal spectrum subgraph. The alpha also just goes to here as planned. And that's all there is to it. There's not ratio calculators the same, everything is the same, just use the absolute world. The map size is important, so I could control the tiling and offset of said texture and then we get the results. And set temperatures work between -1 and 1. So 0.45 is this default, and that's used so that I could actually make cold places, for example, in temperatures of -20, rather than just increase the temperatures. And as I mentioned before, everything, only texture and asset range are default. The spectrum is controlled by and goggle range is controlled globally, and those change the same way as these change through actually equipping said goggles, while heat mask and max temperature and map size works by using the grid temperature manager, and that sets it globally instead of the thermal visor. That's pretty much all there is to it. Oh, and also I'm not using the material overrides for entities because sadly sprite renderers and sprites in general don't work with entities as of yet, so I don't need to actually override property declaration for said things, sadly. But most of those that are preset are not changeable, as only the shaders set global are in this instance, which is quite fast if you would ask me. And that's all there is to it. Thanks for watching.